Are you preparing for the CompTIA Linux Plus certification and looking for a comprehensive guide to master essential Linux system management skills? In this first part of our 4-part Linux Plus prep series, we dive deep into crucial topics like system configuration, kernel management, and service control. Whether you're a beginner or sharpening your skills, this guide provides clear, step-by-step explanations of vital tools like SSH, NTP, SYSCTL, and more. By the end of this part, you'll have a solid foundation in managing Linux systems and be well on your way to acing the Linux Plus exam. System Hierarchy Standard. The File System Hierarchy Standard, FHS, is a crucial concept for anyone working with Linux. It provides a clear structure to organize files and directories, making it easier to navigate and manage the system efficiently. Understanding the roles of the directories is key to system administration, troubleshooting, and automation in a Linux environment. /boot. The /boot directory contains all the essential files needed to start the Linux operating system. This includes the Linux kernel, Linux, bootloader configuration files, and initial RAM disk images, initred or initramps, which load necessary drivers during the boot process. Key files: Linux, the compressed Linux kernel; initred.img or initramps, initial RAM disk, used to load drivers necessary to mount the root file system; grub files, grub, Grand Unified Bootloader, configuration files that control the boot process. Why it's important? Without the files in /boot, the system won't be able to start. This directory should be protected from accidental deletion or modification. The /proc directory is a virtual file system that provides a view into the kernel and running processes. Files in /proc don't exist on disk but are generated on the fly by the kernel. Key contents: /proc/kpinfo, information about the CPU; /proc/meminfo, memory usage details; /proc/PID, each process has a directory named after its process ID, PID, containing information about that process. Why it's important? The /proc directory is essential for real-time system diagnostics. It helps monitor system resources, process statuses, and hardware details, making it a critical tool for administrators. Similar to /proc, /sys is another virtual file system that provides information about hardware devices. It exposes kernel data structures and allows interaction with device drivers. Key uses: inspect hardware devices and their states; change device parameters, e.g., adjusting CPU performance settings. Why it's important? System administrators often use /sys to configure hardware parameters dynamically without rebooting the system. It's integral to system performance tuning and monitoring. The /var directory contains variable data files that are expected to grow over time. This includes logs, temporary files, mail queues, and databases. Key directories: /var/log, system and service logs, e.g., /var/log/syslog, /var/log/auth.log, /var/spool, hold spool files for tasks like print jobs and mail; /var/cache, stores cached files for applications. Why it's important? Log files stored in /var are essential for troubleshooting and auditing system activity. Monitoring the size of /var is crucial because it can grow and consume disk space. /usr. The /usr directory, Unix System Resources, contains user utilities and applications. It holds the majority of the software and binaries that aren't required during system boot. Key subdirectories: /usr/bin, user commands and binaries, e.g., ls, grep, tar; /usr/spin, system binaries for administrative tasks, e.g., fdisk, ifconfig; /usr/lib, libraries required by programs and binaries; /usr/local, locally installed software that isn't managed by the System Package Manager. Why it's important? Most of the software you use on a daily basis is stored here. Separating system binaries and libraries from user binaries ensures that critical system functions remain isolated from user applications. /lib. The /lib directory contains shared libraries that are essential for the binaries located in /bin and /spin. These libraries are used by both the kernel and user-level programs to perform various system functions. Key contents: libraries such as libc.so, C standard library, and kernel modules. Why it's important? If the files in /lib are missing or corrupted, the system may fail to boot or perform essential tasks, as the binaries rely on these shared libraries to function. /dev. The /dev directory contains device files that represent hardware devices such as hard drives, terminals, and printers. These files provide an interface to interact with hardware. Key device files. /dev/sd represents the first hard drive. /dev/tty represents terminal devices. Special devices like /dev/null async for unwanted output, and /dev/0 provides a stream of zeros. Why it's important? System administrators interact with /dev to manage devices, mount file systems, and diagnose hardware issues. For example, mounting a USB drive is done by referencing its corresponding device file in /dev. /etc. The /etc. directory contains system-wide configuration files. These files control the behavior of the entire system and are used by both the operating system and applications. Key files and directories. /etc/password contains user account information. /etc/stab specifies how file systems are mounted. /etc/network/interfaces network configuration for older systems. Why it's important? System configuration is stored in /etc, making it one of the most critical directories on the system. Misconfiguring a file here can lead to system instability or even failure to boot. /opt. The /opt directory is used for optional software that is not part of the default system installation. Third-party applications often install their files here. Usage. Applications like Oracle or proprietary software packages are often placed in /opt. Why it's important? Using /opt ensures that third-party software is kept separate from system-provided packages, which simplifies system management and upgrades. /bin. The /bin directory contains essential command binaries that are required for basic system operation. These are accessible to all users and are necessary for both single-user and multi-user modes. Key binaries. Commands like ls, cp, mv, rm, and bash, the shell. Why it's important? Without the binaries in /bin, basic system commands would not be available, making it impossible to perform fundamental tasks like file manipulation and directory navigation. /spin. The /spin directory contains system binaries that are primarily used for system administration. These commands typically require superuser, root, access. Key binaries. Commands like fdisk, ifconfig, and reboot. Why it's important? These commands are critical for maintaining the system. Only administrators have the permissions required to run most of the commands in /spin. /home. The /home directory is where user home directories are located. Each user on the system has a personal directory under /home where they can store files and configuration data. Example: /home/user1, the home directory for user1. Why it's important? User data, documents, and configurations are stored in /home. By keeping user data separate from system files, it helps in system administration and user management. /media. The /media directory is used as a mount point for removable media such as USB drives, CDs, and DVDs. When you insert a USB stick, it is often automatically mounted under /media. Usage. /media/USB, a typical mount point for a USB drive. Why it's important? The /media directory allows for seamless integration of removable devices, making it easy to access and transfer data. /mnt. The /mnt directory is used for temporarily mounting file systems. Unlike /media, which is often used for removable devices, /mnt is more commonly used by system administrators for manually mounting file systems for troubleshooting or testing purposes. Key usage: manually mounting a partition for maintenance. Sudo mount /dev/sda1/mnt. Why it's important? The /mnt directory is typically used by administrators for testing and maintenance, making it an important tool for managing file systems. /root. The /root directory is the home directory of the root user, the superuser account in Linux. Unlike other users, the root user's home is not located in /home but in /root. Why it's important? The root user has unrestricted access to the system, and their files are kept separate from regular users for security reasons. This is where critical administrative files for the root user are stored. /tmp. The /tmp directory is used to store temporary files created by programs or users. Files in /tmp are often deleted on system reboots. Why it's important? The system uses /tmp for short-lived data that doesn't need to be preserved across reboots. Administrators can use this space for temporary files, but should be aware that files here may be deleted automatically. Understanding the File System Hierarchy Standard, FHS, is fundamental to navigating and administering a Linux system. Each directory serves a distinct purpose, and knowing what files belong where can help you manage the system effectively and troubleshoot issues. In the next section, we'll explore other core Linux concepts related to system.